Now we define what is a quadratic equation. If fx equal to 0 is a polynomial equation of degree 2, that is fx equal to a0 plus a1x plus a2x square, where a2 is not equal to 0, that is called quadratic equation. In general, ax square plus bx plus c equal to 0, where a is not 0, is a quadratic equation, where a, b, c belong to R. Now we take up the roots of the quadratic equation are x equal to minus b plus minus square root of b square minus 4ac divided by 2a, which is equal to minus b plus minus square root of d divided by 2a, where d is equal to b square minus 4ac, which is called the discriminant of the quadratic equation. Further, if d is equal to b square minus 4ac, three cases arise. If d is less than 0, roots are unequal and complex. If d is equal to 0, the roots are real and equal. If d is greater than 0, the roots are real and unequal. Further, if d is a perfect square, then the roots are rational also. If d is not a perfect square, then we say that the roots are irrational. Now we take up the graph of the quadratic equations. Is as follows. If a is greater than 0 and d is greater than 0, roots are real and different. Observe that the vertex is at minus b upon 2a and the minimum value is 4ac upon minus b square upon 4a. If d is equal to 0, the graph touches x-axis at x equal to minus b upon 2a. If d is less than 0, there is no intersection with x-axis. However, if a is less than 0, it takes the following shape. It has the maximum value of 4ac minus b square upon 4a at x equal to minus b upon 2a. Also, when d is greater than 0, the roots are real and different. If d is equal to 0, it touches x-axis. The entire graph lies below x-axis. If d is less than 0, there is no intersection between the curve and x-axis.
Yes, sir.
The relation between roots and coefficients. If alpha and beta are the roots of the quadratic equation ax square plus bx plus c equal to 0, then the roots are alpha equal to minus b plus square root of b square minus 4ac divided by 2a and beta equal to minus b minus square root of b square minus 4ac divided by 2a. Sum of the roots clearly, that is alpha plus beta, is equal to minus b upon a, which is equal to minus coefficient of x divided by coefficient of x square. Product of roots, that is alpha beta, will come out to be equal to c upon a, which is equal to constant term divided by coefficient of x square. Further, if alpha and beta are the roots of any quadratic equation, it can be expressed as fx equal to x minus alpha into x minus beta equal to 0 because of factor theorem, which gives further x square minus alpha plus beta times x plus alpha beta equal to 0, which can be expressed as x square minus sx plus p equal to 0, where s stands for the sum of the roots and p stands for the product of roots. Therefore, the equation becomes x square minus sum of the roots times x plus product of roots equal to 0. Next we find the common roots of two quadratic equations. To find the condition for this, let alpha be a common root of the two quadratic equations a1x square plus b1x plus c1 equal to 0 and a2x square plus b2x plus c2 equal to 0. Therefore, alpha satisfies both the equations, that is a1 alpha square plus b1 alpha plus c1 equal to 0 and a2 alpha square plus b2 alpha plus c2 equal to 0. By cross multiplication, alpha square upon b1 c2 minus b2 c1 equal to alpha upon c1 a2 minus c2 a1 equal to 1 upon a1 b2 minus a2 b1. Therefore, from first two you get alpha equal to b1 c2 minus b2 c1 upon c1 a2 minus c2 a1. And from the last two you get alpha equal to c1 a2 minus c2 a1 divided by a1 b2 minus a2 b1. To find the condition, we equate the two, we get b1 c2 minus b2 c1 into a1 b2 minus a2 b1 equal to c1 a2 minus c2 a1 whole square, which is the required condition for the two quadratic equations to have a common root. Next we find the condition for the two quadratic equations to have both roots common. If both roots alpha beta are common to the quadratic equations a1x square plus b1x plus c1 equal to 0 and a2x square plus b2x plus c2 equal to 0. Now alpha beta are the roots of both the equations, therefore alpha plus beta, that is sum of the roots, is equal to minus b1 by a1 and also minus b2 by a2. And alpha beta, that is the product of roots, will be equal to c1 by a1 and also c2 by a2. From first you get b1 upon b2 is equal to a1 upon a2, and from the second you get c1 upon c2 is equal to a1 by a2. Combining the two, we get a1 by a2 is equal to b1 by b2 is equal to c1 by c2. That means the corresponding coefficients of the two quadratic equations are proportional.